We will continue here the course of EPA 608 Universal Certificate. Now we will start in Type 2 with the introduction. This is the start of Type 2.
In this module, we will go over the EPA's classification method for the types of systems included in Type 2. We will also discuss a few basic concepts required to understand the systems.
An EPA Section 608 Type 2 certification allows a technician to work on high or very high pressure appliances, excluding small equipment and MVACs. Small appliances are covered in EPA Section 608 Type 1. MVACs refer to motor vehicle air conditioning systems. They are covered under a different section of the EPA. As we've defined, EPA Type 2 appliances are high-pressure appliances. A high-pressure appliance is an appliance that operates on high system pressures to convert refrigerant from gas to liquid. Let's review some fundamental concepts to understand this better. Earlier, we mentioned that during the refrigeration cycle, refrigerant moves through a piece of equipment called the condenser. The condenser converts it from gas to liquid. This process extracts heat from the refrigerant, causing it to cool. Low-pressure refrigerants in low-pressure appliances need only minimal pressure to change from gas to liquid. On the other hand, high-pressure refrigerants in high-pressure appliances require a much higher pressure for the same conversion. We will learn more about low-pressure refrigerants in EPA Type 3. Common examples of high-pressure systems include residential air conditioners, residential heat pumps, supermarket refrigeration systems, rooftop units, and high-pressure chillers. A few examples of high-pressure refrigerants used in Type 2 systems are R22, chlorodifluoromethane, R407A, furane, R407C, Freon 407C, R410A, Puron, and R502, chloropentafluoroethane. Memorize this list.
Which of the following refrigerant is not used in Type 2? R407C, R407A, R245FA, R25FA. Which of the following refrigerant would be used in a high pressure appliances? It's R07A.
Regulated refrigerants, as the name suggests, are regulated and have venting prohibitions imposed by the EPA. As of the EPA's latest 2019 updates, regulated refrigerants contain CFCs, HCFCs, HFCs, and HFOs. In this topic, we reviewed the refrigeration cycle and the basics of it, and discussed EPA Section 608 Type 2 systems. We also understood the meaning of regulated refrigerants. Understanding these concepts will help us understand the different techniques and regulations laid by the EPA.
Let's go to K secondary components, introduction for Type 2.
In this module, we will learn about a few components that are not a part of the primary refrigeration cycle, but play an important role in aiding refrigeration appliances to function correctly.
In an earlier module, we learned that the four critical components of the refrigeration cycle are evaporator, compressor, condenser, and metering device. Apart from these, the system's safe and smooth functioning requires a few other components in the refrigeration cycle. Remember, refrigerant is a fluid that flows in the refrigeration system. A storage container is required to store the refrigerant when it is evacuated from the system. This storage container is what we refer to as a receiver tank. To tap refrigerant in liquid form, we have to do it when it comes out of the condenser through the liquid line. Here, it emerges as a high-pressure liquid that can be stored in the receiver tank. We hook up the receiver tank to the liquid line as close as possible to the condenser coil's outlet. This is why receiver tanks are sometimes known as a liquid line receiver tanks. These are commonly used to recover refrigerant from heat pumps and residential split systems that use a TXV or TEV as a metering device.
What is the state the refrigerant leaving the receiver in the refrigeration system? Okay, it is low pressure vapor. No, low pressure liquid. The receiver tank only acts as a storage vessel. This is just storage for high pressure liquid coming out from the condenser coil. It has other function excepting storage, only storage. So the refrigerant leaving the receiver is also high pressure liquid.
When refrigerant flows out of the evaporator and into the compressor, through the vapor line, it's supposed to be completely vaporized. Sometimes, however, there may be some liquid refrigerant along with the vapor. Since the compressor is not made to handle liquid refrigerant, an accumulator tank is attached just before it. This tank collects any liquid refrigerant before it flows into the compressor, where it can cause significant damage. The accumulator tank serves the role of protecting the compressor in the system. It does so by temporarily storing any liquid refrigerant coming from the evaporator, stopping it from reaching the compressor.
Hey guys, this is Craig Migliaccio with AC Service Tech, and today what we're going over is the accumulator tank, its function, where it's located at, and why we use it. So we're going to be going over this, and you want to make sure that you don't confuse the accumulator tank with the receiver tank. A receiver tank is found on refrigeration systems after the condenser coil on the liquid line, and this is before the filter dryer, the liquid line sight, and the TXV. But this is found on refrigeration systems, and it's used to store liquid refrigerant in the refrigeration systems. So on an accumulator tank, this is typically used on heat pumps and also outdoor condensers that have the potential to lose superheat before the refrigerant enters into the vapor compressor. So this is located on the vapor line right before the inlet of the compressor. The accumulator is also found on all of the rotary compressors, and this is always mounted right onto the actual side of the compressor. The accumulator is also used as a storage tank in a heat pump. So during heating mode, there may not be as much refrigerant needed in the system as there is during cooling mode. If you want to learn more about the components used in the refrigeration cycle and also system charging and troubleshooting, check out our book, The Refrigerant Charging and Service Procedures for Air Conditioning. We have this book available over at Amazon.com and also at our website at acservicetech.com. We have a full outline and sample pages over at our website. This tube right here is where the refrigerant enters into the accumulator tank, and this tube right here is where it exits the accumulator tank. So this is where it connects directly from here over to the compressor. So you see that this tube right here inside the tank has a hole here, it has a hole here, and also it has a hole here. So this is the large opening on that tube. So the refrigerant comes in right here, and when it comes in, it should already be in the vapor state. But if it's not in the vapor state, say it's still saturated, what happens is the liquid falls down to the bottom of the tank and the vapor is in the top of the tank. So what you have is this tank is protecting the compressor from any liquid refrigerant entering the compressor. So that vapor compressor can only have vapor refrigerant, otherwise it's going to get damaged. So the reasons for there being saturated refrigerant entering into this tank, and saturated means that liquid and vapor both exist at the same time. The reason that you would have any saturated refrigerant entering the tank is, say on a heat pump in heating mode, if you had the coil frozen on the outdoor heat pump, what's going to happen is the refrigerant is not going to have enough heat to absorb to end up superheating. If it doesn't change states from a saturated refrigerant to a vapor, you're just going to have that mix of refrigerant entering into the tank. So this is going to separate the liquid and vapor, and it's mainly going to have the vapor being sucked into the tube right here, but down at the bottom, if you think about it, you're going to have a bunch of liquid down here. Well, while the system is running, you're going to have refrigerant oil mixed with the refrigerant. So liquid refrigerant and oil are going to be at the bottom of this tank, and in order to make sure that you don't have a bunch of oil stuck down here, there's this little metering device. So this is a screen to protect the metering device, and then there is a small hole down here which is the metering device. So it's going to flash the liquid into a vapor that it sucks from the bottom of the tank, and it's only going to be a little tiny bit, but it's also going to be sucking in the oil down there as well. So the compressor is not going to get starved of oil because all the oil is stuck in this tank. So you have that, and then you have this other little hole right here for vapor, and that's going to help the vaporization. But your main vapor inlet to the compressor is being sucked up right here. So this tube and this are completely separated. So this box is only allowing the refrigerant to come into the tank this way. So this is always above that or over in another direction above that. Another instance in which the accumulator is used is on an air conditioning system that has the potential to lose its superheat before the refrigerant enters back into the compressor. So on a system like that, it's going to make sure that there's not a problem at the compressor. So if the evaporator has superheat, but it's maybe a low amount of superheat, or maybe even say the indoor blower motor is broken and it's not running, the refrigerant has no heat to absorb. And in that case, you have the accumulator, which is really going to be the safeguard for the system. So if there is no superheat, or if there's low superheat, or if the vapor line right here is losing temperature on its way to the accumulator and therefore losing superheat, this accumulator is going to be the protection device for the compressor. Another nice thing about the accumulator tank is it's a storage vessel for the refrigerant, and a good example of that is in a mini split system. So in an inverter type mini split system, this accumulator tank allows the mini split to run with a range of refrigerant inside the unit. So that's what allows you to have, say, a length of, say, 35 feet to 90 feet worth of cumulative line set length, and the system would still work properly. And then, say, the mini split would say, after 90 feet, you're going to have to add so much per foot. Or if you're below 35 feet of liquid line set and vapor line set, then you would have to recover some of the refrigerant. But it's going to allow a range of cumulative line set length, so that's nice. The accumulator and also the filter dryer are the two items that you may have outside. And what happens is this metal is pretty thin. So this metal and this metal are pretty thin. I always try to install the filter dryer inside the building whenever possible. And you notice that filter dryers typically start rusting right where you are brazing the tubing at. And that's because the paint is either melted or burnt, and that's where the rust starts forming at. And then you see the paint can just be chipped right off right there. So same thing with the accumulator tank. A lot of times it's either rusty on the top or on the bottom. This particular one is only slightly rusty, but you can't really see it, but it is rusty under the paint. In these cases, when you're doing preventative maintenance, you can use a spray paint rust primer. So there's such a thing as that. You can also use Plasti-Dip or also wheel well paint in order to try to help seal all of this rust so that it doesn't rust through and cause a refrigerant leak. Now I'm going to take you in for a closer look of the rotary compressor and the accumulator that's attached right here on the side. Here we have a different type of an accumulator tank, and this one's mounted right on the side of this rotary compressor, and this one came out of a window air conditioner, and you have this little screen right here that sits on top of that tube, and the screen has very, very fine holes. So any saturated refrigerant that comes in ends up getting vaporized as it goes through these tiny little holes before it goes into the tube. Also on the bottom here you have a bunch of holes, and those holes are halfway on top of this tube. So all four of these holes are halfway split on this tube. So any liquid refrigerant and then also the vapor refrigerant can be here on the side, so it's going to suck the vapor refrigerant up through the holes and into this tube. So that's how that one works. So this accumulator is what allows a window air conditioner to run so low in temperature. So some people just turn them on and they are running, and say they're in a bedroom, a window air conditioning system's in a bedroom, and the temperature gets down really low. So the system isn't going to have enough heat to absorb to change the refrigerant into a superheated vapor before it comes into the compressor. So this accumulator is the safeguard for this compressor.
Which of the following components is located before the compressor? Accumulator.
A shut-off valve allows the technician to stop the flow of refrigerant inside the system during maintenance to prevent accidental venting. Since it's mostly useful during times of repair and service, it is sometimes called the service valve. As you can see by the arrows in the image, we can change the direction of the refrigerant flowing inside the tubes by pulling it back-seated, or pushing it front-seated. A gauge port is where the service hose or refrigerant gauges connect. To reiterate the positions of the shut-off valve, when it's back-seated, the service or gauge port is closed; when it's front-seated, the outlet port is closed; and when it's neutral-seated, all ports are open. Memorize these positions. The shut-off valve is found in both the suction and discharge lines of an appliance. On the suction side, it is called a suction shut-off valve. On the discharge side, it is called the discharge shut-off valve.
What will backseating a suction shut-off valve close? Suction line and compressor port, compressor and gauge port, compressor port, gauge port. Suction shut-off valve, suction line, suction and compressor. No? Okay, not suction. Compressor port. Backseating a suction shut-off valve will close gauge and service port of the valve. Gauge port.
There are a few other components in the refrigeration system that either support the operation of the appliance or provide ease of access to the technician. We previously mentioned that any moisture present in the refrigeration cycle can result in the formation of acidic sludge if it reacts with the refrigerant, which can damage the components. A filter dryer helps to filter out moisture and other solid contaminants before they react with the refrigerant.
How would you remove moisture from the refrigerant in system? Purge the condenser, drain the oil separator, reduce water flow to the condenser, use a filter dryer.
As the name suggests, moisture indicating sight glass is used to check for signs of moisture inside a refrigeration system via the transparent viewing glass. If present in a system, moisture forms a cloudy mist on the sight glass, just like the mist formed on your car windshield on a cold day.
What is the moisture indicated sight glass useful for? Determine the type of refrigerant, checking the moisture on refrigerant, providing a subcooling, determine the type of oil, checking the moisture
Earlier,
indication.
we mentioned that compressor heaters are used to heat refrigerant oil in the compressor. When the system is shut down for long periods, pressurized refrigerant can migrate to the compressor and mix with refrigerant oil in excess quantities. This dilutes the refrigerant oil and deteriorates its quality and properties. Heating the oil increases its temperature, and since most refrigerants have low boiling points, it boils off any refrigerant present. Heating also facilitates an easy start for the appliance and protects its components from damage due to diluted oil.
What are refrigeration and air conditioning compressor heaters used for? Compressor heaters to reduce the amount of refrigeration oil, to prevent refrigeration evaporation, to reduce the amount of entering water in the receiver, to prevent acid bedding. Okay, to reduce the amount of
Like a
refrigeration
user
in the oil.
manual for an appliance, a system's nameplate provides all the data about a system. A system's nameplate is a sheet containing system specs and data from the manufacturer. This data includes type of refrigerant, quantity of the refrigerant, tonnage of the system, working pressure of the system, and voltage, current, and other electrical details. It may also include additional information related to the system.
What is the easiest way to check the type of refrigerant used in a 60-ton package rooftop unit? Look at the unit nameplate.
In this topic, we learned about the primary and secondary refrigeration components of a refrigeration system. Knowledge of all these components is important in understanding a refrigeration appliance.
Now we finish the introduction for type 2. Let's take the quiz. Okay. In the quiz we have 9 questions. Let's check. How would you remove moisture from refrigerants in system? Purge the condenser, drain the oil, reduce water flow, use filter dryer. What are refrigerant and air conditioning compressor heater used for? To reduce the amount of refrigerant in oil. Yeah. What is the sight glass useful for? Determine the type of refrigerant, checking the moisture and refrigerant. What is the easiest way to check the type of refrigerant? Use the 60-ton package at the roof top. Look at the nameplate here. What is the state of the refrigerant? Where it's leaving the condenser coil into the receiver tank. Into the receiver tank, it's high pressure liquid. What is the back seating suction sort of valve close? What will back seating suction shut of valve close? Suction line and the compressor port, compressor and gauge port, compressor port, gauge port. I'm not sure of this one. Which of the following components is located just before the compressor? Before the compressor, the accumulator. Which of the following refrigerant is not used in type 2? It's R245FA. Which of the following refrigerant would be used in low pressure appliances? Okay, in low pressure appliances, I'm not sure of this one. Would be used in low pressure appliances. This type 3. I don't know, maybe this one. Let's check the correct answer. Okay, submit. Okay, 8.8. Yeah, this I thought it's wrong. Yeah, which one? It's R123. This I expected this one. Okay, so now we finish the introduction for type 2. Let's continue also in this video. Let's take leak repair. Okay, leak detection. Okay, so we finish the introduction for type 2 and we'll take now leak detection.
In this module, we will walk through the different methods to detect a leak in a refrigeration system.
When a refrigeration system is leaking, it means that refrigerant fluid is venting out into the atmosphere. If the leak is not fixed in time, it will result in the loss of all the refrigerant, and the system will become non-functional. When troubleshooting a faulty system, there are visual indicators to look out for in order to detect a leak. If a leak leads to low refrigerant levels in a system, the remaining refrigerant will be subjected to abnormally high levels of pressure. This happens because the system struggles to provide the same cooling effect using a lower amount of refrigerant. As we all know, increasing the pressure will also increase the temperature of refrigerant. An increase in the temperature of the refrigerant in the system leads to high levels of superheat. Excessive superheat in high-pressure systems is indicative of a leak in the capillary tube. Let us discuss this in a little more depth. Superheat is the difference between the actual temperature and the saturation temperature on the suction side. We get the first value by measuring the actual temperature on the suction side of an appliance. The second value, the saturation temperature, can be obtained from the equipment's nameplate. A capillary tube is a thin cylindrical copper tube, a type of metering device generally found in older systems. The thermal expansion valve is also a type of metering device that is relatively new, more sophisticated, and precise. Superheat is automatically kept constant by the TEV. To recap what we've just learned, low refrigerant levels in the system will lead to an increase in temperature. An increase in the temperature of a system leads to high levels of superheat, and excessive superheat is an indicator of a leak in a high-pressure system with a capillary tube.
Which of the following is an indicator of leak in high-pressure system with a capillary tube? High head pressure, low water temperature, excessive superheat.
A hermetic system refers to a system that has a hermetic compressor installed in it. A hermetic compressor has all its major components in one single structure. This type of system is the most common, and can be seen in residential, commercial, and industrial refrigeration systems. As we know by now, one of the functions of refrigerant oil is to seal the system by forming a layer inside its tubes and joints. Any leak in the system would first push out refrigerant oil, so it will be the first substance to be detected. Oil traces on the refrigerant piping or on the floor next to the system are an indicator that the hermetic system is leaking. When inspecting a refrigerant-based system for leaks, traces of oil are ideally the first signs a technician should look for.
When first inspecting a hermetic system known to be leaking, you should look for frost on the tubing, of refrigerant, particles of filter dryer core, traces of oil.
In a belt-driven, non-hermetic system, the compressor motor and the compressor are in different structures and are connected by a rubber belt. Unlike hermetic compressors, this one does not have all its components inside a single shell. It's a type of system that is mostly used in industrial refrigeration. A rotating shaft seal is used at the junction where the metallic shaft connects to the compressor. Rotating shaft seals have rubber seals that are there to protect the system against leaks. If a system has been inoperative for several months, the rubber seals can harden and become brittle, which renders them unable to seal properly.
Trelleborg Sealing Solutions develops and manufactures seals for demanding environments. We offer a broad range of rotary sealing solutions, including the seals known as radial oil seal or radial shaft seal. This seal keeps oil and grease in the system and prevents the ingress of dust and dirt from outside. For high-speed applications, Trelleborg offers Turcon Verilip PDR. In this mixer example, the seal protects the electric motor from oil and grease by keeping the oil and grease on the rotating shaft, and it prevents the ingress of dust and dirt. Rotary sealing solutions are needed in...
To recap what we've just learned, a rotating shaft seal is used at the junction where the metallic shaft connects to the compressor. In a belt-driven non-hermetic system that has not been used for months, the rotating shaft seal is likely to develop a leak.
Which part of belt-driven non-hermetic compressor is most likely to leak if the compressor has not been used for several months? Which part of belt-driven hermetic compressor is most likely to leak? Suction service valve, rotating shaft seal. Yeah.
Let us have a look at some of the methods used to detect leaks in a system. In the absence of obvious indicators, these methods can be useful. Here's a quick refresher on the different types of leak detectors. Ultrasonic leak detectors work by amplifying the sound of the gas escaping a system, and electronic leak detectors have an electronic circuit that detects the presence of particular refrigerants. Both methods are commonly used to pinpoint areas of a leak. Previously, we learned how a soap bubble leak detection test can also be used to pinpoint the specific area of a leak. The soap bubble leak detection test is generally the most effective method as it can be used to pinpoint the exact location of the leak.
To pinpoint refrigerant leak, we use the method ultrasonic leak detector, soap bubble leak detection test.
As we know, the nitrogen pressure test, also called the standing pressure test, is conducted by filling up an evacuated system with pressurized nitrogen gas. A nitrogen pressure test is generally the first thing to be done for newly assembled systems or field pipe split systems. A field pipe system is one that has been installed on-site, unlike a ready-to-install factory-made system. Examples of field pipe system include residential split ACs and heat pumps. The number of leaks present in a field pipe or newly assembled system largely depends on the proficiency of the technician that installed it. This is why it is important to perform a nitrogen pressure test on new systems, as it helps to ascertain that they're leak-free.
After installation of a field-piped split system, the unit should first be pressurized with DOT and with nitrogen and leak check. What is the first thing to do when a new system has been assembled, built up, and it is ready for testing? Pull a vacuum. Okay. Pressurized with an inert gas, pressurized with a refrigerant to be used in system, introduced an initial charge of refrigerant and start. We must pull a vacuum at first. How? Introduce any newly assembled system should first pressurize it with nitrogen and Then leak check.
Earlier, we talked about the use of trace gases with nitrogen when conducting a standing pressure test. If a trace amount of gas is necessary during leak checking, the best choice should be the refrigerant it runs on. For example, in an R407C system, R407C can be used as the trace gas along with nitrogen.
When a trace gas become absolutely necessary, which of the available gases should be used to help locate leak? Nitrogen with HCFC R22 due to its universal system compatibility and miscibility with the various oils. Nitrogen with trace amount of the system designed refrigerant. Yeah.
In this module, we discussed a few indicators of leaks and the particular systems in which they can be used. We also talked about the methods we use to detect leaks, and learned about the use of trace gases when detecting leaks.
Okay, so we are in type 2 leak repair. We are here finishing these items. We finished leak detection and let's go to leak repair. The next module.
In this module, we will learn about the EPA's classification system and leak rates as defined for particular systems. We will also learn about the processes for repairing leaks as defined by the EPA.
There are many different types of refrigeration systems in the market. The EPA classifies them into 4 categories. These categories are based on the purpose each system serves. They include comfort cooling systems, commercial refrigeration systems, industrial process refrigeration, and all other appliances. Let us have a look at each category. Comfort cooling systems are systems used to provide cooling and humidity control in places occupied by humans. Residential houses, offices, and commercial buildings are some of the places you'll find comfort cooling systems. Such systems include chillers, commercial split systems, and packaged rooftop units. Commercial refrigeration systems are appliances used in retail, food, and cold storage sectors. These can be found in locations such as supermarkets, restaurants, fast food vendors, convenience stores, and cold storage facilities for fresh produce like meat and dairy. Industrial process refrigeration is a refrigeration system that is directly linked to one or more industrial processes. Such systems include the complex, customized systems used in chemical, pharmaceutical, petrochemical, and manufacturing industries. This category also encompasses industrial ice machines, ice rinks, and the equipment used to power such refrigeration systems. Note that if one appliance is used for more than just IPR applications, it is only considered IPR equipment if 50% or more of its capacity is dedicated to IPR functions.
In which leak repair category does the EPA place the refrigeration appliances used in the retail food and cold storage warehouses sector? It is comfort cooling, this one. Oh, this is commercial. This which one? Retail food? Commercial. A company using a chiller that diverts 55% of the cooling capacity to one of its manufacturing lines and 45% of its cooling capacity to air conditioning or conditioning the office space. Which category would this chiller be in? It will be, it is commercial, I think also. Oh, capacity of manufacture line industrial. If any appliances use more than 50% of its capacity for industrial process, manufacture line in this case is classified as industrial process refrigeration system if it's more
As
than
we've already
50%.
learned, the leak rate is the rate at which an appliance loses refrigerant due to one or more leaks. The EPA defines the maximum leak rates for each of these systems and categorizes them as we've seen in the previous slides. Just as we say to err is human, no appliance can be made to be fully immune to leaks. Despite the measures taken to prevent leaks, all systems have a minuscule chance of developing a leak on some of its components. Such a leak is acceptable provided it does not exceed the maximum leak rates for the category as defined by the EPA. The maximum leak rate is the highest rate of leaking a system must exhibit in order to require repairs. It is also referred to as the triggered leak rate or threshold leak rate. It's important to remember all these terms. These are the maximum leak rates for an appliance over 12 months. Comfort cooling systems. 10% commercial refrigeration. 20% industrial process refrigeration, IPR. 30% all other appliances. 10%. Remember these numbers. The leak rates in the table are the maximum leak rates as defined by the EPA. They apply for all systems with 50 pounds or more of refrigerant. If the leak rate of a system exceeds the maximum leak rate, it must be repaired immediately.
Starting in 2019, what leak rates triggers or the EPA requirements that mandates commercial refrigeration system containing 50 pound or more of R22 by repair. Commercial, I think it's 20. Yeah.
Now that we know the maximum leak rates for all types of appliances, we know to repair an appliance if it leaks at a rate beyond the indicated maximum leak rate. If an appliance has a leak rate higher than the maximum leak rate, the owner of the appliance has the following options: to repair the appliance, to mothball the appliance or the specific leaking components, to retrofit the appliance, or to retire the appliance. Let us look at each of these options in detail. The most straightforward course of action for the owner of the appliance is to get the leak repaired. After repairing the leak, it is compulsory to verify the results to see whether the system is still leaking, or whether the issue has been fixed. The EPA states that 2 leak verification tests are required after repairing an appliance. A leak verification test is a set of steps that aid in the checking of the appliance's leak rate to ensure it is below its maximum leak rate. The 2 leak verification tests are: initial leak verification test. This should be performed right after the leak is repaired, but before filling the system with refrigerant. Follow-up leak verification test. This should be performed after the appliance returns to normal working conditions, usually within 10 days of leak repair. If any of the 2 leak verification tests fail, it means that the system is still leaking. In such situations, the owner may elect to conduct further repairs or go for any of the other options available. Mothballing an appliance means to evacuate it to atmospheric pressure, isolate it from the other components and temporarily shut it down. As we know, evacuating equipment means extracting all the air, moisture, and particles from a system. Isolating involves separating the appliance or equipment from the rest of the system. Equipment mothballing usually occurs when the repair process is taking too long or a replacement part is not available at the moment.
Which of the following is not required to mothball and an appliance using an ozone depleting refrigerant. Shut down the appliance temporarily, remove the appliance and store it in warehouse at the facility, recover the refrigerant from the isolated section or component, recover refrigerant to at least atmospheric pressure. Not required. I don't know this one. I think recover. Removing the appliance and storing it in a warehouse is not a step included in mothballing an appliance. Okay. Okay, and the other option are activities that occur during mothballing.
Retiring the appliance means putting it out of service and properly disposing of it. If a leak is irreparable, we can retire and dispose the appliance. We already know that retrofitting is the process of adapting existing equipment to accommodate new types of refrigerant. If a leak is irreparable, retrofitting is an alternative that allows the owner to use the system with newer or safer refrigerant. In this module, we discussed the EPA's classification of refrigerant systems and talked about the maximum leak rates for each of these systems. Finally, we learned about the procedures to be followed when repairing refrigerant leaks in a system.
Okay, let's go to the next one, leak repair time frame.
In this module, we will discuss the average time frame for leak repair. We will also talk about the EPA regulations and record-keeping requirements after the leak has been repaired.
If a technician detects a leak in any equipment with at least 50 pounds of refrigerant, the owner or operator of the appliance must get the leak repaired within 30 days of its detection. In addition to repairing the leak verification tests must also be conducted within the 30-day period to confirm the issue is resolved. In the last module, we talked about the two main leak verification tests: initial leak verification test and follow-up leak verification test. The EPA states that the follow-up leak verification test must be conducted within 10 days of the repair. The follow-up leak verification test is only compulsory for appliances with at least 200 pounds of refrigerant.
After the leak, repair of cold storage refrigeration system using 2,500 pounds of R410A and successful initial certification test. When must the follow-up leak verification test to be conducted? The same day, the next day, within 10 days? Within 10 days.
If any of the leak verification tests fail, the owner or operator is required to conduct additional repairs and repeat the process within the 30-day window. If the owner or operator fails to repair the appliance, they must develop a retirement or retrofitting plan. This plan must be executed within 12 months, during which the appliance can be allowed to operate without repair. We already know that natural refrigerants like ammonia, R717, and carbon dioxide, R744, are exempt from the venting prohibition. The owner or operator has 18 months to retrofit or retire a leaking appliance that uses a refrigerant that is exempt from the venting prohibition.
How long does an owner or operator of an appliance with a charge of at least 50 pounds of ODP refrigerant have before they must retire the appliance if it is replacement uses a refrigerant that is exempt from the venting provision? Okay, with a charge of 50 pounds of ODB refrigerant have before they must retire. 12 months, 18 months.
After any system has been repaired for leaks, the owner or operator must get a leak inspection done after a specific time. Leak inspections should be done until the owner or operator can show that the appliance's annual leak rates are lower than its maximum leak rates. Here's a recap of the maximum leak rates for different systems. Comfort cooling systems, 10%. Commercial refrigeration, 20%. Industrial process refrigeration, IPR, 30%. When it comes to comfort cooling systems, or systems with more than 50 pounds of refrigerant, leak inspections should be conducted once per calendar year, January to December. In the case of commercial refrigeration and IPR systems with 50 to 500 pounds of refrigerant, leak inspections should also be conducted once per calendar year. For commercial refrigeration and IPR systems with more than 500 pounds of refrigerant, leak inspections should be conducted once every 3 months. Furthermore, these inspections must occur routinely and show that the leak rate hasn't exceeded 20% in commercial refrigeration systems or 30% in IPR systems over 4 quarters, 1 calendar year.
A customer has an IPR system with 2000 pounds of R22 refrigerant that has exceeded its leak rate threshold. How often is the customer required to perform a leak inspection after repair? Okay, after repair. Okay. Okay. You will make leak rate. Okay. Every month, every 3 months, every 6 months, once per calendar year, once per calendar year. Okay. No. 2000. After repair, after 3 months, every 3 months. Okay, yeah, because it's more than 500 pounds. This is 2000. So it's every 3 months. Supermarket rack that contain 400 pounds of 410 refrigerant has exceeded the applicable leak rate threshold. How often is the customer required to perform a leak inspection after repair? It's 1 year, 1 per year.
In certain situations, the EPA may extend the 30-day leak repair deadline. These extensions may be due to federal, state, or local regulations. The leak repair deadline can also be extended if a component is not available at the moment. However, the unavailability of a certified service technician is not considered a valid enough reason to warrant an extension.
Which of the following cannot be used as a reason to extend the appliance repair deadline? Requirement of state regulation make the repair within 30 days impossible. Necessary components is not available. The appliance is located in radiology contaminated area. Certified service technician is not available. This will not stop the repair.
In this module, we discussed the time frames for repairing a leak. We also learned about how frequently leak inspections are conducted depending on the system. Finally, we discussed the situations that may cause the leak repair deadline to be extended.
Okay, let's check the leak repair regulations. This is the last module. After this, we will take the test.
In this
with the
module, we will
regulation.
discuss the regulations that govern leak repair procedures as well as the requirements for the system after the leak has been repaired.
Now that we know about the deadlines that must be met when repairing a refrigerant leak, let us look at some EPA regulations that guide these repair procedures. It is necessary to find out the remaining refrigerant charge when calculating the leak rate and filling the system with fresh refrigerant. The EPA allows calculations based on component and pipe sizes. This method involves obtaining the refrigerant charge value from the system's nameplate and adding extra refrigerant based on its pipe sizes and accessories. A technician doesn't need to memorize any formula, but this calculation method must be kept in mind.
To determine if a system is leaking more than its maximum rate, the EPA allows the use of which methods to calculate the full charge. Calculation based on the power consumption in kilowatt, calculation based on tonnage, calculation based on component and pipe size, calculation based on BTU of the system, based on component and pipe size. Yeah.
Topping off means to add refrigerant to the appliance without checking for or fixing any leaks. While topping a system with more than 50 pounds of refrigerant, it is necessary to calculate the leak rate first. Seasonal variance is the process of adding or removing refrigerant from an appliance during different seasons. The addition or removal of refrigerant is needed as external environmental conditions go through seasonal changes. Calculating the leak rate is not required when adding refrigerant for seasonal variance.
In which of the following cases will charging a system that contain 50 plus 50 pounds of ozone depleting refrigerant required to be calculated its leak rate? So in which case, okay, required to calculate its leak rate following a retrofit, during an installation of new appliances, during qualified seasonal variance, when topping off system. Okay, required to calculate the leak topping off the system. Yeah.
Record keeping is the task of maintaining comprehensive records or accounts of leak inspections, leak repairs, and the tests performed to verify repairs of leaking appliances. The technician working on the system must provide all these records. As per the EPA, it is compulsory to keep the records for any appliance with 50 or more pounds of ozone-depleting refrigerant for a minimum of 3 years. The owner and operator of the equipment is responsible for keeping these records. As per the EPA, along with other details, the record should primarily include location and date of the recovery, type of refrigerant recovered, total amount of refrigerant recovered, and amount sent for reclamation.
For how long must the owners and operators of regulated appliances with 50 or more pounds of CFC refrigerant keep records of leak inspection, initial leak verification, and follow-up verification tests? For how long must owner and operator keep the record? Life of the appliance? No? 5 years? Okay, this first 3 years.
The owner and operator can choose to maintain the records in hard or electronic copy. The records must be kept on site where the appliance is installed. Technicians and HVAC servicing companies should also keep records of appliances with 5 to 50 pounds of refrigerant when disposing of them. The records of disposal must be kept for a minimum of 3 years.
For what period should an HVAC servicing company keep record for a disposed appliance with charge between 5 and 50 pounds for 3 years?
At times, the EPA requires the owner or operator of an appliance to record and submit a report about the leak to EPA. A report must be submitted to the EPA if the system's leak rate in one calendar year is higher than 125% of the total refrigerant amount in the system. A 125% leak rate would mean that the system once leaked completely, 100% leak. It was repaired and filled back with refrigerant. A quarter, 25% of the refrigerant leaked out again. All of this has to take place in one calendar year. The submitted report must describe the owner or operator's efforts to identify and repair the system's leaks. Other than this situation, it is generally not required to send a report to the EPA. In this module, we discuss the regulations for repairing a leak and calculating the leak rate. We also learned about the record-keeping and reporting requirements mandated by the EPA.
So, in this video, we finish the introduction for type 2, okay, the key secondary components, and we finish the quiz. After this, in leak test for type 2, we finish leak detection, leak repair, and leak repair time frame, and leak repair regulation. Let's take the leak repair test, the leak repair quiz. Okay, and we have 20 questions. Okay, a company uses chillers that divert 55% of its cooling capacity to one of its manufacturing lines and 45% of its cooling capacity to air condition the office space. Which category would the chiller be in? This manufacturing, see, it will be industrial because it's more than 50. A customer has an industrial process refrigerant system with 2,000 pounds. This is more than 500. 2,000 of R22 refrigerant that has exceeded its leak rate threshold. How often the customer required to perform leak inspection after repair? Every 3 months for this one because it's more than 500. Supermarket rack contain 400 pounds of R410 that has exceeded the applicable leak rate threshold. How often the customer required to perform a leak inspection? Okay, for the supermarket, once per year. After the leak repair of cold storage refrigeration system using 2,500 pounds of R410 and successfully initial verification test, when must the follow-up leak verification test be conducted? Within 10 days. After installation of a field applied split system, the unit should first be pressurized with nitrogen and leak checked. For what period should an HVAC servicing company keep the record? For 3 years. How long does the owner and the operator of an appliance with charge of at least 50 pounds of ODP refrigerant have before they must retire the appliance if its replacement uses a refrigerant that it is exempt from the venting provision? I don't remember this one. Okay. That's 18 months, I think. For how long must the owner and operator regulated appliances with 50 or more pounds of CFC refrigerant keep record? for 3 years. Starting in 2019, what leak rate triggers the EPA requirement that mandates commercial refrigeration system containing 50 pounds or more R22 for commercial to be repaired 0.2 or 20%. To determine if a system is leaking more than its maximum rate, the EPA allows the use which method to calculate the full charge, power consumption, tonnage based on component and pipe size. Which of these methods is the best for pinpointing the exact location of a refrigeration leak? It is soap bubble leak detection for pinpoint. What is the first thing to do when a new system has been assembled, built up, and it is ready for testing? Pull a vacuum, pressurize with inert gas and leak check. Pressurize with the refrigerant to be used in the system. Introduce the initial charge of refrigerant and start. Pressurize with inert gas. Add this nitrogen. And check. Okay. When a trace gas become absolutely necessary, which of the variable gases should be used to help locate leak? Nitrogen with HCFC R22 due to its universal system compatibility and miscibility with various oils. Nitrogen with trace amount of the system designated refrigerant. I think this one, I'm not sure of this one. When inspecting a hermetic system suspected to be leaking, you should look for frost on the tubing, puddles of refrigerant, particle of filter dryer core, traces of oil for leaking. In which leak repair category does the EPA place the refrigerant appliances used in the retail food and cold storage warehouse? For retail food, it is commercial. Which of the following cannot be used as a reason to extend the appliance of repair? This is a certified service technician is not available. Which of the following is an indicator of leak? A high pressure system with a capillary tube, high head pressure, low water, excessive superheat. Which of the following not required to mothball an appliance using an ozone depleting refrigerant? Which of the following is not required to mothball an appliance? Shut down the appliance temporarily, remove the appliance and store it in the warehouse. Yeah, this one I think it's correct, but I'm not sure. I think it's correct. In which of the following cases will charging a system that contain 50 pounds plus pounds of ozone depleting refrigerant required you to calculate the leak rate following a retrofit, okay, during the installation of new appliances qualified seasonal variants? Which part of belt-driven non-hermetic compressor is most likely to leak if the compressor has not been used for several months? Okay, suction service, rotating shaft, seal. It might be leak. Okay, we answered all. Let's check our answers. Let's submit. Our answer is 9.5 of 10. Okay, this means there is one Only one question is wrong. In which of the following cases will charging systems that contain 50 pounds of ozone depleting refrigerant require you calculate? Okay, this when topping off system. The correct answer is when topping off system. Okay, now we finished both introduction for type 2 and leak repair. The next one, it will be refrigerant recovery. Okay, and we will take it in another video.